Hello, everyone, and welcome to Clearwater's second winter virtual learning seminar. This program is Highway to the Hudson, the New York State Canal System, and the spread of invasive species into the Hudson River. We're so appreciative to our guest speaker, Dr. Stuart Findlay, the Carey Institute for Ecosystem Studies, to be here to speak with us tonight. For those of you who aren't familiar with Clearwater, we are a member-supported nonprofit organization whose mission is to protect the Hudson River by inspiring lifelong stewardship of the river and its tributaries through innovative education programs and advocacy. So a little bit of housekeeping before we turn things over to Dr. Findlay. Just as some tech notes, this program is being run as a meeting and not as a webinar, so please just be wary of that. So stay on mute during the presentation and discussion. There will be a Q&A at the end. To ask a question, please use the Q&A feature, which is located under More on that menu that's either at the bottom or the top of your screen. We also just want to urge you to be aware if your camera is on or off. But if your camera is on, we or other participants can see you, so just be aware of that. If you're having technical difficulties, Meg and Chelsea will be available in the chat, so you can also reach them under More in the chat, which is boxed in yellow. You can also see the mute and stop video options on the left, also boxed in yellow. So my name is Jen Benson. I'm the Environmental Action Director at the Hudson River Sloop Clearwater, and I have the pleasure of introducing Dr. Stuart Findlay, who is an aquatic ecologist, and he has worked on the Hudson River for over 30 years, researching sensitive wetlands, shoreline restoration, environment critical to guiding the recovery of the Hudson River. He aims to identify impending problems and devise suitable solutions in streams, wetlands, and the Hudson River, and is committed to carrying science forward from discovery to dissemination, and is actively engaged in a variety of management, outreach, and educational programming. So I am thrilled to turn things over to Stuart. I'm going to stop sharing my screen.
Okay. Thanks everyone for joining, and thanks to Clearwater for organizing this webinar. I think the topic is both important and timely, and I'll try and persuade you as to why that might be true as I go through this. And as always, I'm happy to answer questions offline later if there's something I gloss over or completely flub up. We'll try and clear it up either this evening or at other times. So I'm going to share my screen. My mouse doesn't want to work. There we go. Okay, so that's my email in case anybody needs to get hold of me later. So I wanted to speak broadly about managing aquatic invasive species. And I think it's quite useful to separate this topic into two chunks, and they're both quite big and quite difficult chunks. But separate them into what are we going to do or are doing about the invasive species that are already here and are well established and are causing some sort of problems versus the sort of proactive angle, which is what are we going to do or are we doing about preventing new species from coming in. So in the case of existing species, I'll list a few later, but everybody has their least favorite, exotic invasive species. And in general, they dislike it for one reason or another. And sometimes everybody agrees on the reason and sometimes they don't. But they're here and you can see them, you know what they're doing. And so we know what's going on. Because they're well established, it probably means they're widely distributed. And so you have to be pretty strategic and sensible about what you can accomplish The idea of total eradication is great, and if you can do it, it's great. I think it's rare and expensive and difficult. On the plus side, we know quite a bit about, whether or not it might be feasible, how you might go about it, what are the costs, both in dollars and cents and time, and the costs in, you're likely to do some damage in the process of getting rid of these invasive species. And, so for the things that are here, we know quite a bit about what those different parts of the problem are. I'm going to go through 3 examples. They're probably familiar to most of you listening this evening. I'll go through zebra mussels, water chestnut, and common reed fairly briefly in each case, but just to show you the sort of span of, what we're dealing with and how we're dealing with it. The harder part of this is, what are we going to do about the future? It gets way less attention than dealing with what's here right now. It's sort of like, my house is on fire. I don't want to hear about some problem with lead pipes that might affect me 5 years from now. So the stuff that's knocking on your door gets most attention. And it makes sense. But at the same time, we know that preventing future invasions is way more bang for the buck than dealing with what's here now. Because as you probably already know, what's here now is to some extent here to stay. So you're not going to get rid of it. So it's way better to stop new things from coming in if you can do it. The things that are coming are known. Sometimes we know because they're next door. And sometimes they're known because we have models of where species are capable of moving to and setting up residence. And again, the taking action on the future is difficult because there's some unknown hazard that's going to happen. Something bad is going to impinge upon us, but we can't tell you exactly what it is. We can't tell you exactly when, and we can't tell you precisely what the negative consequences are. But it's pretty fair it's going to be bad. Pretty fair guess it's going to be bad. And so, what are we going to do about that? And I think this affects us generally as to our ability to take care of species that haven't arrived yet. I think it's a generic problem, and I'll use a couple of examples outside sort of Hudson River aquatic invasives. But I will come back to touch on the New York Canal System because it is a topic of some discussion right now. So just to set the stage for sort of what we're dealing with as far as species that are present, about a third of the fish in the Hudson are exotic and don't belong there. There are a few that were introduced intentionally. Many of them came in either through the canal or through bait buckets or all sorts of other things. There are a lot of the plants in the river and in the valley that are non-native and have spread, and many people consider them problematic. Most of you probably know purple loosestrife. Japanese barberry and multiflora rose are pretty high on my list of least favorite plants because they have nasty, sharp, pointed stickers. So there are lots of these things around us all the time, and sort of, what are we going to do, and how big an effort, and where and when is really a pretty important question. There's good information on most of those things, and the PRISMs, if you're not familiar with those, it's the Partnership for Regional Invasive Species Management. And depending upon where you're sitting right now, you're probably in either the Lower Hudson or the Capital Mohawk PRISM, but you can go, it's a DEC set of programs. They have local information, they have maps of where these things are. You can report to them if you find things. So again, these things are around us, and there are ways to sort of address the things we have right now. And that's where I'm going to start with these 3 case studies. And again, I'll be pretty brief about each one, but we can always come back. So the first one I want to talk about is one of the few that was identified before it arrived. So there were data on sort of the current state of the Hudson ecosystem before zebra mussels arrived. And it was well established that, they were probably going to do well in the Hudson. The water chemistry is right, and there's habitat for them, that kind of thing. And it was pretty clear they were going to have a big effect on both the phytoplankton, the little algal cells floating in water, as well as the suspended matter. And so, they unfortunately did get here. They were first documented in 1991. Originally, they came into the Great Lakes earlier than that in ballast water, but they're first detected in the Hudson in 1991. The photo at the upper left is just a cluster of them. I think it's on a stick or something like that, just to show you. They're fairly innocuous looking little bivalves, but as I'll show you in a second, they had huge effects. And the figures here, I'll start with the two on the right. Since these things filter feed, and they're very effective at filter feeding, the dashed line is sort of before zebra mussels, and everything to the right of the dashed line. So from 1992 on is after zebra mussels. And they had obviously just a huge effect on both the phytoplankton, which is measured by chlorophyll A, the pigment that they carry, as well as one of the taxa of zooplankton, that's rotifers. Many other zooplankton suffered the same fate. Abundances went down by 90% or more after the zebra mussels came into the system. And the figure on the left is sort of the good grief panel. So it's the percent of the Hudson that's filtered per day by zebra mussels. So if there were no zebra mussels, it'd be 0. And you see that the figure goes up to 100. The long-term mean is sort of 40-ish, but it's saying that somewhere between 40% and 100% of the Hudson water is filtered every day in the summer by the zebra mussels. So they're very, very effective. They obviously live on the bottom, but they're very effective filter feeders. And so they're constantly taking things out of the water, like the algae and the zooplankton that I spoke about before. So we knew they were coming. We documented what's happened here. The effects have gone on past where these figures stop, but they're definitely still here. Many of the problems they cause are because of their high abundance on hard substrate. So they'll settle on floating docks. They'll settle on boats that are left in the water. Some of the biggest problems are in water intake pipes, either for cooling water or drinking water intakes. Right now, it doesn't appear they're a huge problem for the Hudson drinking water intakes, but at times they have been, and other places they have been. So it's a nuisance for infrastructure at the very least. All right. So again, well-documented case of what's here and what they're doing, both to the natural system and to things we put in the water for our uses. So in the case of zebra mussels, I haven't said anything about getting rid of them, right? Because we're not going to get rid of them. If you're lucky, you can get them out of your water intakes, you can get them off your boat, you can get them off your dock, but we're not getting rid of them in any, measurable amount at all. Okay, they're just here. So the second thing I want to talk about is water chestnut, and this is a plant you've all seen if you take the train back and forth to the city, the bright green patches, and I'll show you some aerial photos in a minute, along the shore or sometimes further out in the river, or water chestnut. This plant was introduced more than 100 years ago by a botanist at Harvard who thought it was a lovely little thing to have in the pond, and it got loose and spread across the Northeast quite a long time ago, at least 50 years ago. It sort of did most of its traveling. And it probably moved as people move boats around. It may have moved through waterways. The seeds float, and many of you have probably seen the seeds. Down in the lower left on that paddle is one of they call them devil club heads, but they float around. And so they're pretty good at transporting the plant to new areas. And where it's capable of living, it's gotten to and sort of set up business. In the case of the Hudson, through aerial photo inventories, we have good records of where it is and where it's not, going back over 20 years. So we have a good sense of just how much of it is out there, and where does it tend to occur. This is sort of the poster child for the problem with water chestnut. This is Imbach Bay, just south of the Rip Van Winkle Bridge. This is the biggest bed of water chestnut on the Hudson. It's about 1 million square meters, give or take. It fluctuates a little bit. And if any of you have ever tried to take a kayak or a small boat or even a big boat through this stuff and thinking you can plow through, the answer is no. It's extremely difficult to get through, and you can get stuck and actually be in a fair amount of trouble, hung up in these dense plant growths. The plant is floating at the surface, which is why it's so easy to see in the photos. In this particular site, as the water is exchanged with the tides, the high tide water come in and fill up the bed with fresh river water, which has essentially the amount of oxygen it carries from the river, which is close to saturation usually. But as it sits in there, the respiration of the plant's roots, basically, in the stem, and all the other things going on in that bay remove the oxygen. So after one tidal cycle, just a few hours, by the time the water comes back out, it has zero dissolved oxygen. And so we tend to think of dissolved oxygen problems as coming from sewage inputs. But in this case, we've got a habitat that's covered by this exotic species that's generating, very low dissolved oxygen water and kicking it back into the river every time the tide ebbs out of this bed. This effect does not happen in very small patches, but for the few very big ones, it is a significant drain on sort of the oxygen content in the river. The other ecological effects are that it definitely shades out other plants. In this close-up, the water chestnuts on the left, and on the right is water celery, incorrectly called eelgrass sometimes. It's Vallisneria americana. But where water chestnut occurs, it shades out the native water celery. And the water celery is widely recognized as important food for animals, waterfowl. It's a net producer of dissolved oxygen in contrast to the water chestnut. Huge numbers of invertebrates live in there, small fishes. Very valuable habitat and valuable ecologically. But where water chestnut is present, there's no light and there's basically nothing living under it at all. Well, no plants living under it. There's lots of stuff living under it, no plants living under it. So the control, now here's a case where there's been management of this plant for quite a long time. And the current control is largely for recreational access. This is done in marinas. This is a aerial shot of just south of where Rondout Creek comes in. So Kingston is to the sort of upper left there, would be up to the upper left there. And, a brave group of someone has gone out and cut channels through the water chestnut to provide access to beaches. There's actually, I think, a small marina in there. There's park. And so just to be able to get even small boats back and forth, you need someone to cut channels through the water chestnut. And at this scale, it's quite difficult. And most of this kind of work is being done with mechanical harvesting. And there's a photo here. There are a number of different kinds of these mechanical harvesters that basically chop the stuff up and ideally get it out of the river and get it on shore. Don't just turn it loose, because then you're just spreading it and it disperses better. Historically, there was a very effective attempt to eradicate the plant. This was in the late 70s, 80s. And it worked, but it was using 2,4-D. And so the decision was that the cure was worse than the affliction, and this stopped. And not surprisingly, water chestnut pretty quickly grew back. Areas that have water chestnut and have had it for a while, there's a seed bank in the sediment. And depending on who you talk to, the seed bank will persist for anywhere from 20 to 50 years. So you can get rid of it one year, looks great, it'll be back next year. And so if you decide you're going to do the kind of management to either clear a very small area or clear a big area, you got to recognize you're going to be doing this for a while. And that's fine, but it comes back to my point of, know what is going to take you to achieve your goals, what are those goals, and, what's going to cost and how long is that going to going to take. Don't go into this with your blinders on because you'll be disappointed. So that's the water chestnut example. So it's a widespread plant, causes some pretty negative things. There are some management options, although you're not, well, if you want to go back to 2,4-D, I guess maybe you could eradicate it, but I don't think you'll get that through the process. So the last case I want to talk about, the last sort of case study I want to talk about is Phragmites australis. It's called common reed. It's called ditch reed. Again, you've all seen it if you've driven around or taken a boat almost anywhere by the road, or many wetlands in the Hudson Valley and other places have this plant to some extent. It's tall, has a sort of feathery head. And its introduction is kind of a strange story in that what we see around us today is a hybrid of a native reed, Phragmites australis, a native variety of reed that's been here for thousands of years and was not invasive, did not spread rampantly. And what we have now is this hybrid with the European strain. And the European strain probably came over in solid ballast. This was before, way back before there was water ballast on ships with solid ballast. So you're bringing heavy material from wherever you start and you just dump it when you get to wherever you're going. And there'd be all kinds of seeds and plant debris and all sorts of things in there. And so it's likely that this European variety came over through that avenue, unknowing at the time. And the two hybridized, and the hybrid is clearly invasive. And I'll talk a little bit later about some of the negative effects it has, but it's pretty widespread in the tidal wetlands of the Hudson. Probably every wetland has some, and it's highly variable. And this is a point I'll come back to. But again, for those of you that do the train ride back and forth, just sit on the east side of the car instead of the river side of the car on the way down, and you'll see, once you start looking for it, you'll see it in the wetlands. Sometimes a lot, sometimes a little. Again, with aerial photos, there are good records of the spread of this plant. You can, see in the earlier photos, little patches that get started. And then once they get started, they pretty much spread out and take over from everything else. And so they just grow radially and can eventually come to dominate a site. And I'll show you an example in a second. It crowds out almost all the other species. There are a few other plants mixed in with it once you get a mature, dense stand of reed, but not nearly as many as there would be otherwise. So it's bad for biodiversity. There are some birds and other wildlife that like it, and there are many other things that don't like it. And so, again, if we'll get to talking about management of this thing, but again, what do you want? Who are you trying to help by managing this? It does have some things that are considered positive attributes. Wetlands are supposed to put away carbon and get carbon out of circulation. They're supposed to remove nutrients and sort of clean the water. You've probably all heard of the people talk about kidney function of wetlands. And this plant is very good at that. And it's actually put into artificial wetlands that are designed to clean up wastewater because it's so good at getting, the stuff out of wastewater that you don't want to discharge to water bodies. It actually provides some benefit in shore zone protection. It'll dampen down some wave activity. It'll keep debris from coming up on shore. So it has some things that people consider positive characteristics. And so it's back to this point of, if you're going to manage it, what are you trying to achieve and why are you trying to achieve that? And just be very clear about what you're trying to do. Don't just, it's an invasive plant, we have to get rid of it, end of discussion. That for the things that are here, that's not a good path to follow because you'll drive yourself nuts. Okay, so here's an example. These are two of the Hudson River National Estuarine Research Reserve sites. On the right is Tivoli Bay, and the little yellow blotches are small patches of Phragmites. They were a couple acres in the beginning. And on the left is Iona Island Marsh. And again, the yellow is reed, Phragmites, and Iona Island is about 70% covered, was about 70% covered with Phragmites. So the research reserve and parks, well, the research reserve at Tivoli Bay said, we're going to get rid of these patches of Phragmites before they get bigger. Because again, they had evidence that they were growing. They were still relatively small, but they were expanding. And there was a desire not to just sort of let them go until they took over the entire marsh. And so they went out and they killed the reed. It involves herbicides. It's a glyphosate-based herbicide with a surfactant for water application. There's a lot of controversy about using herbicides. It does work. It did work. They've basically gotten rid of these little patches. And I think it's a wise thing for them to have done. And I think they did it as carefully as could be done. And native vegetation is back. They didn't have to do any reseeding or anything like that. On Iona Island, they had a good argument that songbirds had really been hammered by having so much Phragmites present. And so they went in and in several of these patches you see, they did the same thing and got rid of them with glyphosate. Obviously, they're using a lot more glyphosate. It's essentially Roundup. That's not what it's called for water applications, but it's essentially Roundup. They're using a lot more of it, and the chances of having leakage and spills and stuff like that go way up. So to me, if you can get them in this sort of young stages, the small stages, it's easily justified to deal with them because we know where it's headed. We know what's going to happen. When you get to these bigger sites where you're talking about a much more significant operation, it becomes questionable. Should you just say, okay, it's now a different marsh, it's doing different things, doesn't have songbirds, does put away carbon? Where do you draw the line on whether to take action or not? The good thing about the Hudson is there have been studies of many places where this has been done. We know that you can get rid of it with glyphosate, and it's kind of a personal choice as to, not personal choice, professional choice as to whether you're going to do that with that herbicide or not. There are some options for mechanical containment, and Constitution Marsh, which is run by Audubon, has taken sort of a brute force approach. They essentially go in and roller down the Phragmites to get it laying flat, and then they get a bunch of people to go out there and cover it with it's a heavy black fabric, and so it gets hot enough under there to kill the plants. The trick is you have to kill the below ground portion, the roots and the rhizomes, because it has an extensive rhizome system. You have to get it hot enough to kill all that, and then theoretically you take the plastic up, the fabric up, and native plants will recolonize, or you might need to do some planting of native plants. So for really small areas, there's a chance for mechanical control or even containment. But once it gets past, I'm going to guess an acre or something. It's just, this is backbreaking. I've never done this, and I would never sign up to do it, but it sure looks difficult to me. But it does work, and they've been doing it for years, and I believe they're pretty happy with it. So I'll just rehash the three examples pretty quickly. So zebra mussels, there's here, management-wise, there's nothing we're going to do about them. Just recognize it's a different system. They have effects that we pretty well understand. They may change in the future, but they're sort of part of the system now. Water chestnut, it's unlikely we'll ever really get rid of all of it. It's highly unlikely we'll ever get rid of all of it. And we know what its pluses and minuses are. And, we know that it can be controlled if you're willing to take a pretty, long-term repetitive view on what needs to be done. And Phragmites, again, I think it's there's some urgency here in that the sooner you get the small patches, the better, because once it gets big, it's more difficult practically to deal with. And there's much more controversy about using those amounts of glyphosate to do the control, unless you're going to come up with some other approach. So that's the stuff that's here. And I want to talk about the things that are coming. And I will talk about a couple of examples that are sort of on the horizon that are coming. But part of the trick here is that we don't know exactly who's coming 20 years from now. It's given the history, it's almost certain things will keep arriving. Some will get a good toehold, some will spread, some will have negative effects, but we don't really know who they are for the really long term. And it's not 100% sure just exactly what their effects will be, although given the number that are arriving, some will have large negative effects. That's given the history track, that's pretty much guaranteed. So it's kind of weird in that we know there are going to be problems. We know how those problems arrive. We know that it's cheaper to prevent than remove. But, generically, we have not done a good job on sort of looking ahead and dealing with this stuff that's, on the horizon or even, down over the horizon we don't even know about. Yeah, so I'm going to talk about a couple of examples that have certainly gotten people's attention. And these two examples, it turns out they're both fish. And this is why there's been a fair amount of discussion about canal management, because the fish would very likely move through the canals. Well, one already has moved through the canals, and the other would certainly be capable of doing the same thing. So I'll talk about two things that are either here already or looming, but as difficult as it is, try and think about the stuff that we don't know about yet. It's the unknown that I think is where the big danger is, but it's also the best thing to stop. Get it before it really gets started. So there are things you can do once something is close to invading. So it might be in a few spots in the region, but it's not widespread in the region. And for those of you that have small boats, you've probably been through sites where they have boat stewards and they do an inspection, and they'll talk about, clean off your trailer and check, flush the bilge, and what's in your bait bucket and where do you get the bait, and do you know what kind of things you have in your bait bucket. And this is great work. It's effective work, and it's going to slow things down once they're kind of in the region already. And by region, I probably mean sort of 50, 100 miles. This is the kind of stuff the prisons spend a lot of time doing. And again, I applaud their efforts for doing this. But I want to take on the harder part about looking longer, both longer distances and coincidentally, longer time frame. So we know that aquatic invasives come through many different ways. I mean, some come on boats, on trailers, some come from bait buckets, but many of them come from long distances through 2 or 3 main pathways. One is ballast water exchange. You may or may not know, but as ships go across the ocean or travel long distances, they need ballast to sort of keep them stable, and they'll pick up water from wherever they leave. And then when they get to wherever they're going, as they're changing their loads, they might exchange that water. And so you've got the ship transporting water from Europe to the US. And so for zebra mussels, for instance, that's what happened. They brought water and zebra mussels. There are now rules that say you have to exchange your ballast water at sea. And so you take the freshwater things you picked up from Europe, dump them in the middle of the ocean. They don't survive. You pick up seawater, come over here, and if you exchange it, you're dumping seawater organisms into freshwater. They don't survive, and it's less of an issue. The practicalities of ballast water exchange are tricky. You're not going to get every gallon of water out of one of these big tankers, and they can't be completely empty of ballast either. So there's a pragmatic angle to trying to get good ballast water exchange. But the regulations and practices have improved. So this is not as big a problem. I think it remains a problem, not as big a problem. Some of the best examples that are in the news right now come through the pet trade. And I'll bet you dinner that everybody on the call has heard about the constrictors in the Everglades and what a big problem they are. And they were almost certainly released by someone that got a cute little snake, and all of a sudden it turned into a not cute big snake. The snakehead fish is in New York State. It's not in the Hudson watershed yet, but again, it was almost certainly an aquarium release that got too big for someone to handle, or they moved, or for whatever reason they turned it loose. And we can do better than doing things like that, and it's a question of education. I want to spend the last 10 minutes maybe talking about this artificial connection of waterways. And the photos here are the canal system. These happen to be on the Erie Canal, but it would be similar for many parts of the canal system. And, you know, the Erie Canal is what made New York the Empire State. It was very important for commerce. It was a major transportation pathway that opened up the Midwest, that allowed people to move long distances and move their products long distances. And it was very effective at that. And still is a hugely valuable resource. There's lots of recreational use. There's lots of fishing that goes on there. It's got a historical aspect that people really like. You know, there's a bike path. You can ride your bike the whole distance. It's a very valuable resource for the state. That's the good news. The less good news is we now know that many species move through it. As you know, these locks open and close to let boats through several to many times a day. Any exotic species can move along, can just, you know, it's an open highway to go from largely the Great Lakes. Most of the stuff's coming from the Great Lakes down into the Hudson Valley, and some goes the other way. So given this, we have what I call the wheel of misfortune in New York State, and that we've got these waterways that link Ontario to Canada, basically, the St. Lawrence Seaway. We've got the Erie Canal that links the Great Lakes to the Hudson, and we've got the Champlain Canal that cuts across a watershed divide and links the Hudson to Lake Champlain. And it's well established that species have moved at their own will back and forth along these canals for hundreds of years. In some cases, the actual date of introduction is very well known. In other cases, it's not so well known. But you can see the numbers here. There are 160 exotic species in the Great Lakes. Hudson has 90 something, Champlain has 60 something, and these numbers are undoubtedly, excuse me, out of date. So there are lots of species that could move around through these canals, and this issue has been known about for a long time, but it has sort of come to the front a bit lately. And the reason for that is this little fellow here, not a very impressive looking fish. It's the round goby. Came into the Great Lakes with ballast water, 30 years ago, 30 plus years ago. Gradually, it moved through the Erie Canal to the Mohawk River. There was essentially no action to try and stop its movement. So it took 6 years. It had to, climb up to what used to be the watershed divide just west of Rome, New York, and then made its way down into the Hudson and was found in the Hudson in 2021 and is now found widely in the Hudson. I'm not sure the abundance is terribly high yet, but it's been found all up and down the Hudson. And the fear is that it's going to move up the Champlain Canal into Lake Champlain. And so that has not happened yet. And there are opportunities to do something about this. And there are a number of things that are underway. And I think this is a case where we really need to be looking at the long-term, best solution, most effective solution here. And that is that the Army Corps is quite far along designing plans for what they call hydrologic separation. It's kind of a euphemism. Basically, what they mean is putting a physical barrier at the high point of the canal, the point that used to be the natural watershed divide, and stopping the movement of water back and forth across that watershed divide. I quickly point out that these plans do allow for boat movement around this barrier. I'll talk about these. I'm going to talk about the boat aspect in a minute, but I'll talk about the other group of fishes that are causing pretty high concern. So the invasive carp, again, I'm going to guess many of you have seen videos of the jumping carp. If you haven't, I encourage you to just Google jumping carp, and it's pretty scary stuff. These fish, it was a deliberate introduction over 50 years ago. They were brought in to help clean up aquaculture ponds because they eat the grass carp in particular eats a lot of plant material. I'll show you maps. They're all through the Midwest. As of right now, they're not breeding populations in the Great Lakes, and there are huge expenses and huge inconveniences to try and keep them out of the Great Lakes. Because once they're in the Great Lakes, they're in all the Great Lakes. There's nothing to stop them moving one to the other. And from a Hudson point of view, once they're in the Great Lakes, they're going to head down the Erie Canal, and we really don't want them. They're damaging ecologically. They're very damaging to recreation. And again, if you look at these videos, you'll get a sense of why that's the case. Here's their distribution. This is actually old. They have probably spread past there, but not into the Great Lakes as of yet. They're blocked out basically at Chicago, and we could talk about that in questions if you want. They've been kept out so far, but if you look at that, it's like, you know, there's something knocking at the door, and there are a lot of them. And even though you got the door locked, you kind of fear that, you know, something's going to slip through. And then once, as I said, once they're in the Great Lakes, they're through all the Great Lakes, and that's going to be a huge problem. I think I'll just show you one example of why almost everyone is opposed to having these things invade a system. So this is the adult sport fish. So recreational fishing, as I said, in both the canal and in the Hudson and Champlain and the Great Lakes, is a huge moneymaker. You know, hundreds, thousands of people, millions, tens of millions of dollars spent to go sport fishing. And so this is for, I believe this is the Illinois River, but I could be wrong. This is a well-designed study that looked at 3 sites that did not get invaded by these carp, and 3 sites that did get invaded. And there's a big difference, you know, some 15 years after invasion, in the abundance of sport fishes. So the sport fish are doing fine in the sites that aren't invaded, and the sport fishes are going down in the sites that were invaded. And this is a logarithmic scale. And so that difference is about 3-fold. So there are about 3 times as many sport fish in the uninvaded sites as the invaded sites. So I think for the invasive carp, nobody wants it. No one has come forward and say, oh, I see a silver lining to this invasion. Basically, everyone's on the same page as far as keeping these things out. And so the question is what to do about the canals. I mentioned before, physical barrier. And as soon as you start talking about this, there's kind of a knee-jerk reaction that, oh, you want to close the canals? And the answer is no. Nobody wants to close the canals. They're a valuable resource to the people of New York and other states for that matter. They provide benefits recreationally, historic as well. And so that's not what we're trying to do. We're trying to deal with this problem before that's forced on us. And so what has been suggested by 2 separate, I think pretty well-designed planning efforts and studies is to do this hydrologic separation, which is a physical separation at the old watershed divide, for both the Erie, which would be west of Rome, and the Champlain Canal, which would be about 2/3 of the way up. And this is what they've come to recommend. The design plans aren't terribly detailed at this point, but they're talking about moving, for the Champlain at least, boats up to 100 feet. There is no talk about trying to move barges because that's probably just not feasible. So barge traffic would be stopped. There's no question about that. Not much question about that. But for many, if not most, of the recreational vessels, there would be a lift, a little drive, get cleaned up, and then put back in. So is it an inconvenience? Yes. Would anybody, look forward to this experience? Probably not. I happen to think that is probably a necessary thing that's going to have to happen. And my point is, let's do this. If we're going to do this, let's do this in a thoughtful way and not once we get to crisis mode. And the last example I'll talk about is what was basically a crisis mode situation. The Fox River in Wisconsin that feeds into Lake Winnebago, they found VHS, which is a pretty nasty blood disease carried by some fishes that had not gotten into Lake Winnebago. And so they said, look, this thing is here, close the locks. They just close the lock, and that was the fastest and most effective thing they could do because they really did not want this thing in the lake. And the last I heard about this is they are still struggling to get a hoist, to get what I just talked about, a system for moving, reasonable sized boats, up and around, and so they can pass this closed lock. I would frankly rather we do this the other way around, that we design ahead of the problem before we get into sort of this crisis mode, and deal with this proactively and not, once we're faced with a very uncomfortable decision. So I'm going to quit in a second here. There's stuff everyone can do. And the first is, and I suspect you're all well aware of this, is don't move plants and animals around intentionally or unintentionally. Just pay attention to what you're moving around. You can report invasives. There are good apps that will allow you to identify what the particular invasive is. And if you report it, it puts a dot on the map, kind of like that map I showed you for the carps. And this is very useful information for letting people know where these things are, how quickly they're moving, where they're abundant or where they're perhaps still in low densities. You can work with your prisons, and they can teach you sort of, here's what we're looking for, here's what we're doing about it. And both those first two deal with things that are already here. This looking down the road and dealing with stuff way in advance of having a significant problem, as I said at the beginning, it is not easy. People don't react well to sort of vague threats that they can't put their finger on, that they can't see, that they haven't, seen happen to their neighbor or happen in their neighborhood. And so in order to get something done, it's going to take a lot of political will, because the solution that have been proposed, these, barriers in the canals, are not going to be popular. They're not necessarily going to be cheap. It's not going to add convenience for the boating community. So that there's going to be, unhappiness about this. And so the best thing I think we can do is get all the cards on a table and talk about what needs to be done. And we need people to take it seriously. We need people in government to take it seriously and say, let's really talk about this and figure out how we're going to get in front of this and stop just being reactive and start being more proactive. So with that, I'm going to hand it back to Jen, I believe, for a minute, and then we've got time, some time at least for Q&A, or I'll talk to people afterwards. I'm happy to do that. Thank you.
Great. Stuart. I'm going to go through this quickly on my end over here. But as Stuart mentioned, there are things that folks can do in addition to taking action in terms of mapping current invasives or preventing transport of aquatic invasives that are already here. But we also do have opportunities to call upon our state government, specifically Kathy Hochul, to act to stop invasive species from entering the Hudson River watershed through the Erie Canal. For the sake of time, I'm not going to say more than that, and I will send this out via email. So please do put your questions in the Q&A box, and I will send out this action alert. A couple of other things about Clearwater. We would love to have you come out sailing with us this season. We'd love to have you get further involved with us. We also want to invite you to attend our remaining winter virtual learning series, which is about PCB fish consumption advisories, which will be next Monday, February 26th from 6 to 7. I will be your featured speaker. And then we also want to invite you to Gala. Stuart is a remarkable scientist and researcher, and he's actually one of our honorees. And so we welcome everyone on this webinar to join us on Sunday, April 7th at the Garrison from 3 to 7 to celebrate Stuart, our other honorees, as well as another great year on the Hudson sailing as Clearwater. And now I'm going to stop sharing my screen and we can do questions. I think we already have a couple in the box. Thank you, Chelsea, for throwing the links in the chat. Stuart, one question. It seems like with the early days on the Hudson that sports fishermen are an important constituency. Is there traction there?
I think there is, and there are a couple of people that have been very good about getting out and sort of raising awareness about this. And there are a couple of DEC folks that are doing it, and there are a couple of people that are working with a little task force that are trying to get the word out to the sporting communities. Because again, they recognize that this is not a good thing, and apparently the question is always, what can I do? What can I do to help this? And to a large extent, it's trying to get other people to take action. That's what they need to do. So building, taking advantage of the strength of that constituency to speak with one voice to say, we want something done about this, and we want it done before it's a disaster. When it's a disaster, it's a disaster.
Yeah, you can't put the fish back on the other side.
You could try, but I wouldn't bet a whole lot of money on it.
That makes, yeah, if only. They say hindsight is 20/20, and I think in some cases it really is. And we have another question. Over time, is there evidence of native species adjusting to the presence of non-native species and returning to some sort of balance?
Things change. It's pretty typical that in the first 10, 20 years, you get big fluctuations. And then things do commonly settle down to some extent. So for instance, with zebra mussels, they're having a much harder time reproducing and getting to a big size than they used to. And it is likely that certain things have figured out to eat them. And so if there's an abundant resource out there, something's going to figure out how to use it. It's probably blue crabs, not 100% sure, but probably blue crabs. So yeah, things do sometimes have a way of settling down. And that's good. The question is, do you want to go through 20 years of pretty significant unhappiness before you get to that? And it may not come. And I think in general, we're better off not monkeying around by putting these species together. And so they'll figure it out and they'll learn to play nicely together eventually. That may work, but I don't think it's a very robust foundation for managing what's going on out there.
Absolutely. You have to be proactive, because otherwise we're going to just be further destabilizing our already vulnerable ecosystem. I was wondering if anyone else has any final questions that they want to throw in the Q&A box. And I guess, Stuart, my question for you is, if we went through a lot of information, we saw a lot of case studies. If you had to put it into like a 2-sentence top takeaway for attendees tonight, what should they be bringing back to their neighbors or to their boat clubs or to their fishing clubs in terms of this topic?
Yeah, so I think it's pretty straightforward in that, we have to be more focused on prevention. As I said, it's easy to get, so busy taking care of what's standing here irritating you right at the moment that you don't worry about, oh, there's something that's coming, perhaps unknown, and we don't know what it is, but it could easily be worse. I use the analogy, and maybe this will help. It's like trying to shoot the rocket into space to divert the asteroid that's headed to Earth. The further away that asteroid is, the smaller the rocket you need to launch, and the cheaper the rocket will be. You just need to move it a tiny little bit to get what you need. If you wait until that asteroid's in the atmosphere, it's over.
Well, I think that that seems like a great place to conclude tonight. Thank you so much, Stuart. We really appreciate your time and you coming on with us to share your knowledge of this issue. I'll be sending out the recording and we'll be putting it up on YouTube, and we'll be sending around the action alert as well. But yeah, as finally, thank you both to Stuart and to all of our attendees, and we hope you'll consider joining us at either the last virtual learning session next Monday or at our annual gala or out on a sail at some point this season. But thank you everyone for being here, and we hope to see you out on the water soon.
Yeah.